Hello all and welcome back to my channel Data Sculptor. Today we're going to see how to um, generate insights and show some visuals in a Power BI report using data of one of a store. This is a sample data. So basically a small store in one of the area sells some products like mobile, shoes and TVs, and they have some data generated. So we as a data developers, say as a data analyst or data engineer or BI developer, use this data and let's generate some insights and let's generate some visuals out of this data. So let's understand what's the data we have. So first, we have some columns. Those are name, age, gender, city, state, country, product, sales amount, sales date, return stock, return date, and feedback. So all these columns are self-explanatory, so nothing new in this. So we have the sales amount. So let's see based on this data what all insights we can generate as a data analyst. What all insights you can generate? So first thing you can generate is total sales. So total sales which is generated by this store, say over month or over quarter or over year, or total sales till now. And next thing is you have let's go one by one columns. You have this age of the customers. So maybe we can categorize the age into age groups, say 25 to 30, 28 age, the age of person 28 belongs to 25 to 30, and similarly 40 belongs to 35 to 40. Similarly, you can generate some age groups, and based on the age group you can see which age group is purchasing more in the store. And next thing is male versus female. So male versus female, using the gender column, you can see who is generating the maximum sales and who is returning the maximum stock, and what is the mood of the customer. So whether male is happy or sad, or whether female is happy or sad, generally based on the combination of feedback and gender, we can decide the mood of the customer. And sales, and next thing we have the geography, city, state, and country. So based on the country, which country is generating the most sales, and similarly next thing, which country is returning the most stocks. And next thing is weekends versus weekdays. So you have this sales date column. So each of the sales day has a weekday associated, whether it's a Thursday, Friday, Saturday, Sunday, or Monday. Um, in most of the cases, Saturday and Sunday are weekdays, but for sorry, Saturday and Sunday are weekends, and other days are weekdays. So based on this data, we can see whether most of the purchases are happening on weekdays or on the weekends. And next thing is average time taken by customer to return the product. So average time taken by customer is nothing but difference between sales date and return date. And average time, we can take the average and generate the sales date minus return date. And next thing is number of customers per mood. So you have different feedbacks: happy, sad, very happy, and all. And we can see the number of customers. So we can see based on this the percentage of sad versus very sad versus happy and all. So based on this percentage, we can decide whether whether the customers who are attending the store are happy or sad about the products they buy. And the mood of the customers as per geography. So sad, moderate, very sad, and all per geography. So for every country, or what is the mood of the customer. So if is the USA citizen happy while buying the product, is the Sweden citizen happy while buying the product. So based on the country, you can see the mood of the customers. And for products, you have mobile, TV, and shoes. What is the average sales for each of the product? And next thing, products having the most returns. Similarly for products, which product is having the most return stock. So so based, these are few of the insights which you can generate out of this very little data set. So imagine a data set, say Amazon transactions or a bank transactions. Based on the data, you can see how many insights you can generate. um, so as you know, you need to have the passion to understand on the data so that you can generate the insights. And once you generate the insights, you can generate the visuals. Based on the insights and visuals, you can increase the business of that organization. So that's why big organizations like Microsoft, or say a small any organization, um, they always hire data engineer or any data developer related roles, so that they try to increase the business using uh, these people. Okay, so now as a data developer, sorry, as a data analyst, we have generated all the insights. I mean, we have decided what all insights we'll be generating. So now as a data engineer, we'll see how to with this data how we can generate these insights. So a data engineer for the past 8 years, I always use facts and dimensions for any data set available, because that is, I feel, that is the best way in order to generate more number of insights in the minimal development effort. So facts and dimensions. Dimension is nothing but a single dimension gives you the information about a single reference, about reference of a single entity. So that means uh, name and age and gender. These three are related to a customer. So customer is a dimension. So customer data is present in this base data. So customer is a dimension. The customer can data here. If you see, they have all the required dimensions. In fact, so customer is a dimension. Customer can have a name, age, gender, and also the age group, as we discussed earlier. We need to make sure that each and every dimension has distinct value, has a primary key. So in this case, the primary key is name, because a say age can be repetitive for multiple customers, and gender also can be repetitive, age group also can be repetitive, name also can be repetitive. So in that case, ideally we generate keys, but for now, for just for sample, let's assume that these are different names. Okay, the customer names are not repeating, that let's assume that, but in ideal case you might have customers having the same name as well. So next thing is the customer geography, city, state, and country. So city, state, and country is the geography of the customer, and here we know the city, state, and country geography is in a hierarchy. Hierarchy means um, city is the lowest, least green, or the primary key. One city cannot be present in two states, and one city cannot be present in two countries. Uh, and but one state can have multiple cities and one country can have multiple states. So that's why city is the granular column, and this is the primary key of customer geo. And next thing you have is um, product. Product information, you have mobile, shoes, and TV. Product, product, you have mobile, shoes, and TV. But for this data set, you can have only one column. But in general, you have a lot of properties of product, whether what is the color, what is the cost, price. You can have n number of properties. But for this simple data set, we are keeping only one column called product. And next is date. You have two columns called sales date and return date. So you combine all the dates present in these two columns to a single column called date. And as we discussed in the insights earlier, we need to generate insights based on the weekdays versus weekends. So for each of the day, we have generated the weekday. And next is you have the date, you have the return stock. Return stock is simple yes or no. Let's create a single dimension, separate dimension for this. Return stock yes or no. And next thing is feedback. Feedback, you have five items, or five values. Feedback is nothing but very sad, sad, moderate, happy, and very happy. And yeah, these are the simple dimensions you have. And you need to have a fact table. Fact table is nothing but a table which generates fact or some quantitative value out of the table. So in our case, we have the sales amount. So sales amount is uh, is a quantitative value. So this sales data, you have the sales amount, but sales amount you need to split on all. This sales amount is category, I mean, associated to all the dimensions in this table. So instead of copying this entire table, we'll denormalize the table such that redundant data will be stored in the dimensions and only the required data will be stored in the fact table. So in the sales table, you have only the name column compared to the main table. You do not have in the main table, you have name, age, and gender. But in the sales table, we have only the name column because that is the granular column. So basically, this is the foreign key. So all the primary keys of the dimensions should be present in this fact table wherever required. So for this the customer table, the name is the primary key, and for the geography table, city is the primary key. For the product table, product is the primary key. Sales date and return date, let it be. Since there is a single dimension date, let's join that date with sales date and return date. Return stock also is a single. Um, Return stock is also a single yes or no. Feedback, sad, moderate, and all. Sales amount, whatever values you have in the main table. So one thing you need to note, you need to consider, a sales table does not have any granularity. That means there is no primary key associated with sales amount, with the sales table. Okay. So now I hope we are clear. Now we have generated the required insights. The data analyst has generated the what all insights we require from the data, and the data engineer has created all the tables. For now, I have created this manually, these tables in Excel for us to understand how to generate facts and dimensions. But in general, a data engineer uses a lot of techniques. Say, if you are using an on-premise, they use SQL to generate these tables out of the base data. So you create a lot of stored procedures and keep that in a job, in a particular sequence, or in a, say in an SSIS package, whatever way you have, you can keep those stored procedures, and such that whenever the new sales data or the main data is updated, this data should be these facts and dimensions should also be updated. So data engineer takes that responsibility to create all these tables, create the pipelines required such that the data refreshes on a frequency basis, and that is the data engineer's work. And now let's create Power BI report. I have already imported these tables inside the Power BI report, um, uh, inside this Power BI report, and so we don't have the relationships as of now. Okay, these are column one, column two, and all. I think date, weekday, we have feedback column one, we have product column one, return column one. So let's see the data of customer geo. Date, we have feedback. Okay, I think these are not okay. I think sales and all, everything is mapped. Everything is imported. So now let's. Uh, I think there is while importing there is some issue. Instead of column one, city, state, and country. So what we'll do? So let's clean this data. So for customer geo, let's click on edit query, and let's make sure that we clean the data. Um, so city, state, and country. So okay, I have city, state, and country. This is city. I'm renaming this columns. I think while importing, okay, I think I will close this file because it's not able to import the data or update the data in the Power BI. Okay, yeah, now, okay, yeah. So this is the column name is return, and if possible, to delete. So let it be. Let's have these values. It will be okay if we have these values. Ideally, these values should not be there. Sales, sales is okay. It has imported correctly. Return, the dimensions are not proper. Feedback, customer geo. I'll remove this. Change types. Yeah, this is city. This is state, and this is country. So now I have renamed. So I will filter out the data. I'll remove city. I'll select all but remove city, and similarly for feedback, I'll remove everything. I'll select everything but remove this feedback. Uh, and similarly for product, I'm removing product. Basically, here what is happening while importing the data, we did not mark the headers properly, so that's why this is happening. um, yeah, so let's close and apply. So after we close and apply, we see that the all the rows are written properly, and city, country, and state. Now all the, now the data set is clean. We have cleaned the required data. So now let's go to the model view. So now basically let's discuss about relationships. So relationships, fact table. So you have this fact table and dimensions table created. So now it's our duty to join the fact table and dimension table. So we need relationships in a Power BI or a data model, because we need slicing between the dimensions and the facts. So slicing means where if you want to see the sales date or whatever data from the sales table with say with the state or city, you need to join these tables. Then only you can see the sales amount based on the city. If you do not join these tables, you will be not seeing the correct values. So that's why you need to join this all the dimensions with the fact table. So you have multiple types of relationships. So main relationship we use, or the simple relationship. So how to create a relationship? Just use the primary column of the dimension table and its corresponding foreign key column in the fact table. So customer geo and sales I'll join with city column. So I'll just drag this city and join it with city. So if I click this here, you can see the property city and city, customer geo, many to one, many to one. So if you click on this drop down, there are many types of cardinalities. So many to one to many, and many to many. So many to one because um, say many to one means sales, um, the column, the city column in sales is repeated, whereas the city column in customer, that is on the one side, is distinct. So that's why one should be means the one. So here one means the distinct and many means repeated, and similarly one to one means there are distinct values of the column in both the sides of the relationship. One to many means similarly one of the side is having a distinct and the other side of the relationship is having duplicates. Many to many means duplicates present on both the sides. Okay, so many to one. So here it is a many to one because cities values are repeating in the sales table. And you see one more thing called cross filter direction. Cross filter direction has single and both. So basically cross relationship cross filtering direction means you see the direction here. So you have the one to many, you have the direction pointing towards sales, from customer geo towards sales. That means uh, you can use the customer geo dimension to slice the sales data dimension data values, but you cannot use the sales data or whatever columns are present in this particular table to slice the customer geo values. Let's see more about this in the coming part of the video. Let's give the relationships now, and here it is date, and here date. uh, okay, date, let's keep data. So return, you have return, no return. Where is return date, return stock? Yeah, I think you have to join with return stock. It's a yes or no. Similarly, it's one to many. Basically in facts, dimension to facts, dimension will always be on the one side of the relationship, and fact will be on the many side of the relationships. And product, here you have product, here it is one to many. Product to sales, feedback is also one to many. And what more do you have? You have date. So date, you'll join it with the uh, sales date. Sales date, you see, if you see here, the date is on the many side here. What I'll do here, date, I'll click and I'll click this one to many. The cardinality you selected is not isn't valid for this relationship. Okay. Why is it? Maybe because you have some duplicate values in this date, and I have distinct values in this sales date. Ideally, this is wrong. So yeah, and similarly, you have the return date as well. So date and return date also you need to join. But if you see, there is already a relationship between both the tables. You cannot have a active relationship between two multiple active relationships between two tables. So I'll reopen the Excel, um, because there are some duplicates in the date table. So let's fix this. Uh, let's fix the duplicates. So in the date, if you see, are there any 5, 6, 7, 8, 9, 10, 12? Yeah, if you see, there are the 12th, March 12th is repeating, 14, 15, 16, 17, 18, 19, 20, 22, 24, 25, 27. Yeah, now it's a distinct. Yeah, now we have saved this. We have fixed this duplicate issue um, in the tables. We have closed this, and now let's refresh this. Let's go back here and refresh the date table here. We are refreshing the date table because we have deleted the duplicates. So just click on refresh data. So yeah, now the data is created. Let's go back to the model view and now see if it's one to many is working or not. Yeah, now one to many is working because now the date value have distinct values. Earlier it's not working because there are some duplicates. Now it is active. We have made this relationship active. We need return stock as well. Um, so date to return date, I'll keep a relationship uh, which is an inactive relation. So if you see, there is a dotted line because between two tables you cannot have more than one active relationships. So if you need to if you need to have multiple relationships between two tables, you need to have only one active relationship and you need to have inactive relationships between those tables. Okay, I think now we have created the required relationships, one to many relationships, and also cross filter direction is single. So there are two basically there are two single and both. Ideally we use single based on the requirements. So we can use both as well. So both means nothing. So suppose if here cross filter direction is single, that means the data which is on the uh, the data which is on the one side of the relationship can slice the data which is on the many side of the relationship. So this is the arrow is going from this table to this table. That means this table can slice this table. So if I change it to both, you'll see a double arrow. That means double arrow means this table can slice this table as well as this table can slice this table. So both the tables can slice each other. But as of for now, we don't want this. We want only single filter direction. But in your day-to-day projects in your office, you can based on the requirements you'll change the directions of the um, of this model. So this is a simple star schema model which we have created. So uh, now we have created the model. So now it's our time to generate um, the visuals. So as discussed, the visuals. Let's reopen this Excel. Um, so we have earlier written all the um, required requirements or the required insights. So first thing is total sales. So total sales. So you have this sales table and here you have this sales amount. So always you need to create measures for whatever insight you want to generate. You need to create measures, and on those measures you need to slice using the dimensions. So sales amount is a measure, but if you see in this data total sales will be an accurate one only if that stock is not returned, right? So you cannot sum up this entire data and show that as a total sales. You need to sum only the sales amount where the stock is not returned, correct? So now let's create a measure called new measure, and here the measure name is total sales. Total sales is calculate. You have to use DAX here. Calculate sum of sales amount and filter sales, comma. We want return stock is no. So wherever the stock is not written, that amount only we're considering it as total sales. So total sales is there. So here it is total sales. So now let's use a visualization. So you have multiple visuals capability in Power BI. So let's take card for example, and you can just drag that. You can select that measure. So if you see, you have a total of $9875. So basically, if you sum this amount, you see around 9875 $9875 is getting generated. So now next let's see if the total sales over month. Okay, basically we don't have the month. For here for now we have so date hierarchy is automatically created in Power BI. You have this feature year, quarter, month, and date. So if you drag the month, let's see if okay, since card allows only one measure, it does not allow dimension. So let's create a table out of this. So total sales is 9875, and let's use the month. So you have only 2 months data, March and April here, sales date. So here in March it is showing 7,600, in April it is showing 2275. Okay, so I think now we have generated the first one. And next thing is which age group is purchasing more in the store. So which age group? So similar now, I'll copy this. How to see if, the age which age group is purchasing more. Now instead of month, I'll just deselect month here and go to age group. Age group we have it in the customer dimension. Um, okay, where is the customer dimension? Customer dimension is missing. Okay, uh, okay. I think here customer dimension is missing. So let's we need to close this again and import that data. So yeah, let's click on Excel workbook. I have this data here in this location, and I think I'll select the customer data here. So name, age, gender, and age group. I'll click on load, and okay, it's pulling the entire data. So the customer data is full now. Earlier it was missed, and here by default the direction by default Power BI auto detects the data and gives the relationships. In the settings, you can disable that relationship, but for now it's okay. It is joined on name, and let's reopen that mod. Let's reopen the requirements. Okay. So now the second question is which age group is purchasing more in the store. So now we have the total sales, and let's use the customer dimension age group here. Yeah, if you see here, 30 to 35 age group is purchasing more in the store, and next followed by 25 to 30, next followed by 35 to 40, and then 20 to 25. So I think we have generated the second output, and next is male versus female, maximum sales, maximum returns, mood of the customer. Okay, so now let's copy this again. And the third one is age group is done. Now it is gender, right? So I'll remove the age group. I'll keep gender, male versus female. So female, for gender female, you have the most sales. Now this one we are able to get. Next is maximum returns. So maximum returns is nothing. The sales amount, we need to create one more measure, total return sales. So let's create new measure called total return sales. Total return sales is nothing but same, calculate sum of sales amount, comma, filter of uh, sales, comma, return stock is equal to yes. So if the stock is returned, then only that is called the return sales amount. I think we have created the measure. Now in the same table, gender we have, I'll keep this here, and now I'll drag the return sales also. Okay, so now return sales if you see here, female have the total maximum sales, but male is having the most, males are retaining the most products which are bought. And the next is mood of the customer. Mood of the customer means, mood of the customer is basically the number of customers, uh, the number of customers in each. So basically, mood of the customer means, the number of, we need to have the male versus female in the mood, and the total number of customers. So let's create one more measure called total number of customers. So all the dimensions you need to always create on the fact tables. Just remember, you should not create on the dimensions. You need to create on the fact tables. So total customers is distinct count of um, sales of distinct count of sales name. Yeah, this is count of sales of name. So this will give you the total number of customers. So now I'll copy this. I'll get one more table. Okay. Here you have, I'll remove this sales and total sales. I'll use the total customers. So gender, you have 10 female and 10 male. And now, since we want to know the mood, let's use the feedback column as well. So if you see here, let's sort by customers. So female customers with the, out of 20, uh, four of the female customers are very happy. Three of the customers, female customers are happy. And okay, let's see the percentage. Okay, instead of total customers, let's see the total customer percentage. So one more measure let's create. Uh, okay, I think it's okay. I think let's, it's 4 by 20, uh, 3 by 20. So if you see, this is the ratio. So very happy. Um, Female customers are very happy. Out of 24 of them are very happy, and happy also, 3 of them out of 20 are happy, and male very sad, female moderate, male happy, like this. So out of 20 customers, these are the feedback, and this is the how you see the mood of the customer versus gender. And next one is, one more measure let's create. It's called customer percentage. uh, Percentage, it is divide, um, distinct count of sales of name, comma, calculate of uh, okay, I think, sales of name, comma, all of, all. I am not sure if this works. Customer percentage. Okay, I'll rename this. I'll keep this as a percentage. Yeah, yeah. If you see now, it is customer percentage nothing but it is four total 4 by 20, 3 by 20, and similarly customer percentage. So basically, this is the percentage. We have created the customer percentage, and now create one more table, and let's see feedback and use customer percentage. So if you see here, let's sort by customer percentage. So most of the customers are under happy or very happy only. And next is moderate, sad, and very sad. So I think the store's owner will be very happy because most of these customers are happy and very happy. I think this is now how we can get the mood of the customer. And next is simple sales by country. So let's create one more table. You use total sales, and here in customer geo you use country by sales. I think with this you'll get which country is generating most sales. Just sort it by total sales. So South Korea is generating most sales, and Australia is generating the least sales. And return stock by country. So now inside this, let's use the return sales also. And now in this, let's sort by return sales. So if you see return sales, UK is returning the most uh, sales. I mean, people from UK, they are returning the stock, the most stock, but their total sales is zero. That means basically um, uh, entire citizens who are from UK, they're returning the entire stock. Basically, Vietnam and all. Basically, here that means these people are returning the entire stocks. Maybe you can create one more. You can generate one more inside percentage of return sales. That means um, how much percentage of sales people are returning. But that's okay. UK and all. This is how you generate which country is having the most return sales and which country is having the least return sales. These people not even returning anything. And next is weekends by weekdays. So now same thing. Let's create one more table. And so one more table, weekend by weekdays. So we have the total sales, and you have date. You have the weekend by weekdays, weekday column here already present. So it's day, Monday, Saturday, Sunday. So basically here again sort by weekday. Sorry, sort by total sales. So Tuesday, Monday, Sunday, Friday. These are, so basically here this is the weekday. Sort by weekday. So this is how the purchase is happening. Tuesdays the purchase is more, and Wednesdays the purchase is least. And next is average time taken by customer to return the product. So that means average time is taken by customer to return the product. That means you need to find the difference between the sales date and the return date. So for this, I'll create one more measure, or say maybe one more column I'll create, which is difference between sales return date and sales date. Return date will always be greater than the sales date. So return, let's name the column as return days. This return date minus sales of sales date. So but we need it in number of days. So is there a date diff function here? Date diff, date one, date two. This is going to return the number of. So if I say okay, sales return and sales date. The sales in interval is, I need it in days. So I'll write day and click on enter. So now the return days convert NA of the type NA. Yeah. So if I mean basically we need only sale. I mean we need this only if the return value is yes. So if return stock is equal to yes, then date if, else let's keep it as blank. So yeah, now the return days is created. And let's create one more measure since we want the average. So new measure, return days average return days, or average return days. This is average of uh, we don't want the column. Yeah, we want the column. Average of sales return days. So this will give us the average return days. So now you have created the column. So now let's click on this column, average return days. So let's go back to the table. If it is minus 5, I think let's go back to this data model and see how it is created. -7, -8. I think something is wrong. I think it is sales date minus the first value should be the sales date and the second value should be the return date. Hmm. So first is sales date. I think we have kept this wrongly. Sales date and return date. Okay, so basically in 5.33 days, if the customer wants to return, is returning it basically in 5.33 days. So if you want to see by gender, let's go back to customer dimension and drag the gender column here. So females are returning in around 6.67 days and males are returning at 4.67 days. So this is one of the insights which we wanted. Number of customers per mood. Number of customers per mood is something which we already created here. And mood of the customers per geography. So here, mood of the customers per geography. Mood of the customers per geography also we have created. I mean, here we have mood of the customers per gender. So now here, instead of gender, I'll keep geography. So geography means let's check it by country. I think almost everyone is it's equal. Happy, sad, everyone is equal. Uh, that's how the data. So basically, this data in this particular data set is not making sense. But if you have a large data set, this will give you some valid output insights. Average sales of each product. So you need to create average sales. Um, so let's create one more measure called average. Average sales. So it's just simply average of sales amount. Okay, sales amount. But here we want only as we want as we want only um, the return stock to be yes. I mean the return stock wherever the stock is not returned, that only um, we need to consider the average. Return stock is equal to no. If the stock is not returned, then only we'll calculate the average sales. Okay. So now average sales, we have generated the average sales and product. Okay, these are the different charts. So by this you can see the comparison by this bar graph. Shoes has the most average sales, and mobiles have the least average sales, and the products having the most returns. So products having the most returns. So you have the products have most returns. So basically, you need to select return amount. Where is you have this total return sales. You can select the product and product having most returns. So yeah, if you see shoes, there are people are returning shoes mostly, and TVs they're returning less. Okay, so yeah, this is some of the insights which we have generated using Power BI. I mean, in the Power BI, I have created the UI and all is not perfect, but you need to spend some time to generate a proper UI, so that and also so that it will be the user will be it should be very easy for the user to attract to understand the report. Also, you can use filters. You can create a slicer and based on this required insights, you can keep this filter, say product. Okay, I think we have, if you use product here, so if I select shoes here, these are some of the insights might not be valid, but some of the insights will be valid. So for shoes, if you select, you can see the total sales by month and also total sales by age group and all. So some we can keep any number of products, any number of filters, and see the required output. So yeah, this is how a simple Power BI report which we have created based on simple store data. Uh, if you have any other insights, I think based on this data which you can generate, you can post it in the comments, and so that we can group and try to understand how where we are missing out. Hope you like this video. If you like this, please like, share, and subscribe to my channel. And also, if you really like this video, I'll come up with more some examples and see. Let's see how to generate more insights out of this data. And if you feel that you have any other interesting data sets, you can provide me the data sets in the comment section. If you can share the data sets in the comment section, so that let's generate some insights out of this new data sets which you share in our further videos. Thank you. Have a nice day.